Okay, so for the next part, let's talk about your next graph, which is your velocity time graph or your speed time graph itself. Same thing, your same 3 to 4 steps. First thing, we want to check your axis. You want to check whether this is a velocity time graph or a speed time graph. So like I mentioned just now, the only difference between this is that one is scalar and one is not scalar. Speed time graph are only positive values. Okay, there is no negative values for this. Number 2, you want to check your units, whether they are SI units and whether you need to do any conversion. Okay, because sometimes they are not in the proper units itself. Maybe it's kilometers per hours, for example. And number 3, we know you want to find your gradient. It's y2 minus y1. So in this case, it's v2 minus v1 over t2 minus t1. And if you notice, this is v minus u over t. This is actually your acceleration. So apart from just these 3, there's actually a 4th one for speed time and velocity time graph. Displacement or your distance, depending on which one you use, is equals to your area under the VT graph. Okay, so this V can represent either your velocity time or your speed time graph itself. Okay, so basically it's the area underneath. So you can see these 2 points over here. All right, and anything below your horizontal axis will give you a negative displacement. So first things first, when you have a horizontal line, your gradient, which is your acceleration, will be 0. So what does that mean? I am moving at constant velocity because my velocity is 40. And if you notice over here, area under the velocity time graph will give us displacement. So every second, you're moving at 40 meters per second. So for 16 seconds, you'll move a total of 640 meters. Okay, your displacement equals to V times T. V times T will be just 40 times 16. You get 640. Okay. Next, the one that we are more familiar with when we have a diagonal. Therefore, you will see uniform acceleration. And this is a upward sloping gradient. So this is a positive acceleration. Okay. And next, if you take a look at the diagram here, what shape is this? This is a triangle. So your displacement will be half VT. So half, in this case, 80, and the time is 16. So in this case, same thing, you also get 640. Just a coincidence, okay? So do take note about this. Just remember, not all the time you'll be a triangle. It might be a trapezium like this. So if it's a trapezium, you'll need to use your trapezium formula, where S is half A plus B times height, where the parallel parts are your A and B, A, B, and your height will be the non-parallel side. Okay? Now for your curves, you need to be careful. Same thing, because this is getting steeper, you have increasing acceleration. So don't worry, for curves, they will not ask you to calculate the distance or displacement because there's no formula that you learn in your current syllabus that allows you to do that. Typically, it's either late set 4 or JC level. Then you learn how to calculate area under a curve. But apart from that, you don't learn it in secondary school. Okay? But they might ask you to estimate it because if you look at this one here, it looks kind of like a triangle. So some schools will actually teach you the different method, but you can just assume that most of it is actually either a trapezium and a triangle, and basically see which one suits the occasion best. And then you just use the corresponding formula. Okay, so similarly, this is getting gentler. So we call that, you will have decreasing acceleration. So for those who are still having trouble with whether it's increasing or decreasing, just grab your ruler, put it along your line, and ask yourself, is this steeper or gentler? Okay, it's because some of you are too lazy to take it out, and therefore you make careless mistakes. So just please be careful about all of this. You don't want to make all these small little mistakes and get your full marks. Okay. Next, Now, if you notice over here, this is downward sloping, right? So this is a negative gradient. In this case, negative acceleration. So negative acceleration, this is your deceleration. Okay? And next, you ask yourself, take your ruler, because I cannot confirm, it is getting steeper and steeper. It's getting more vertical, right? So because it's getting steeper, this is increasing. Okay, so this is increasing what? Increasing deceleration. Okay, so you can see over here, because you're getting steeper and you have deceleration. Okay, so now let me highlight to you something. This is your displacement, right? This is still positive because you are above your horizontal axis. If you think about it, what does this picture represent? Basically, my object is moving and it's actually slowing down. Okay, because remember, you have increasing deceleration. So as time passes, you are slowing down more and more until you come to a stop. Okay, but in this case, you can see at 16 seconds, you come to a stop. So what happens is basically you are still moving forward. So this is your displacement. You are still moving forward, just that you're slowing down. Okay, you're slowing down to a stop, but you're still moving forward. Okay, so it takes time for you to be familiar with all of this, but once this kind of clicks in your head, it'll become much easier for you to understand and interpret all these graphs. Because some students, they only hard memorize, you all don't understand what is happening and what does it mean to have this kind of graph. Try to picture in your head what actually happens, because basically with the graph, I can actually find almost everything. Because if you notice, in this graph itself, I have your velocity, I have your time, I have your acceleration or deceleration in this case, and I also have your displacement. Basically, I have all of the components I need. I have displacement, I have velocity, I have time, I have acceleration. So basically, using just one velocity time graph, I can actually find all of this, which is basically all the components you need to actually find out what is going on with your object. So a velocity time graph or speed time graph is much more common than a distance and the displacement time graph. So you must be very, very familiar with this. And if you notice why we don't use the word negative acceleration is because, like I said before in the previous video, we try to avoid using the word negative in your motion itself. Because when you see negative, it's just a meaning of direction. But for your deceleration itself, we can make full use of it because this doesn't include the word negative. So feel free to straight away use it as it is. So same thing for this. You have decreasing deceleration because you're actually getting gentler. So how to check? Just grab your ruler, which a lot of students don't. And you can see that you are getting flatter and flatter, flatter and flatter, and gentler and gentler. So same thing, same logic as before, you are still having positive displacement until you come to a stop. Just that this one, you brake very fast and then you slowly release your brakes. So because that, you will slow down slower near the end. Okay? So like your displacement time and your distance time graph itself, first thing, we want to do your checks. 1, 2, check 1, check 2. Okay? All good? Check number 3, what is your gradient? The gradient will be your velocity over time. This is your acceleration. Number 4, you want to check your area under graph. Area under graph itself, over here, it is your displacement because this is a velocity time graph. So, same thing, we break it up so into parts that we can understand. Increasing acceleration, constant velocity, uniform acceleration, and then at E, you have decreasing acceleration, and this is where it gets a bit different. Okay, All right, so for F itself, you can see that this is now a downward sloping. So downward sloping means you have deceleration. And what happens over here, you have increasing deceleration. And this one over here, you have uniform deceleration. So you can see in F and G, basically this is your need to change your phrasing a little bit, okay? But the one that you need to highlight is whenever you touch your horizontal axis, whenever you reach zero, you need to be very, 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 very careful. Why? Because when you reach zero, there are three things that can happen. First thing, you can remain stationary, which is what happens at H. You can either speed up, basically you accelerate, which is just going up, or you can actually reverse direction. Okay, which means that you actually become negative velocity, as what you can see in this diagram over here. Okay, this negative velocity part is the one that you need to be careful of, because remember, we don't use the word negative. So instead of the word negative itself, you will see that you use the word in the opposite direction, But the one I want to highlight to you is this point here. Okay? If you just take a glance at your eye, normally this downward sloping, we will say that it's actually uniform deceleration, right? But because you're actually under the graph, what happens here is you become a more negative number. So from 0 to a more negative, what it means is that you're actually speeding up in the opposite direction. So you actually have uniform acceleration itself. So whenever you have any graph that is underneath your axis, you will always need to flip the sign. Your positive become negative, your negative become positive. So normally, I interpret this as a uniform deceleration. I flip the sign, it becomes uniform acceleration, but I will include the word in the opposite direction. Okay? So similarly to your J as well, you are normally this is your uniform acceleration, but because it's in the negative below your horizontal axis, I'll flip the sign and it becomes uniform deceleration in the opposite direction. Okay, you can put the in the opposite direction at the back, or you leave it as this format, it's fine. Okay, so next, let's take a look. Now, not all the time you are expected to describe the graph. Sometimes you are actually expected to draw it instead. So I'll give you the information and you are expected to finish it. To start and finish at rest, you have decreasing acceleration, 5 seconds. You have constant velocity of a certain value for another 3 seconds. And you have uniform deceleration at the last second. So first things first, you want to plot your points. So first thing, 5 seconds. 5 seconds is here. And then what happens at 8 seconds? Then after that, 1 more second afterwards, 9 seconds. Okay, and they tell you at start and at the end. All right, so decreasing acceleration for 5 seconds. First thing, we don't know any values, so we don't know what it will be. We know that the shape looks like a curve. Okay, it will become gentler and it's upwards because it's acceleration. So then they tell us you have 1.6 at 5 seconds. So over here. And this will be continuous for here. Okay, so all I need to do now is grab my ruler and make sure that 1.6, this is a straight line, constant velocity, and then I have uniform deceleration because I start and end at rest. And then for this part, the curve, now when we want to draw a curve itself, first thing we will choose either the 0 or the 5, right? I'll draw at a 5, which is easier. So normally if you want to curve, you want to move a little bit horizontal first before you start to curve down to a vertical. So like this is how you're supposed to draw your graph or your curve more easily. Do it in one single stroke. If you keep erasing itself, you'll find that it gets harder and harder. So if you can, as much as you can, draw a nice single straight line. Okay. Next one, your displacement is your area under your velocity time graph. So state how it's found, right? So basically you want to say that it's area under velocity time graph because this displacement. And then for your distance traveled after 5 seconds itself, 5 seconds is over here. So basically, they're asking you to find the area of this trapezium over here. So area of a trapezium is half A plus B times H. A plus B is 5, 8. This is 3 on top. 5, 9. This is 4 below. So 3 plus 4. And your height is 1.6. So altogether, you get 5.6. If not, what you can do is actually find this rectangle. And you can find this triangle. Okay, so you can actually separate them and then solve. But if you know the trapezium formula properly, you can actually straight away use your trapezium formula if you know what the numbers are. Okay, next, let's take a look at your displacement time and velocity time graph itself. Now, in the displacement time graph, your gradient is your velocity, right? So if velocity is 0, because this is horizontal, velocity 0, velocity always 0 here. Make sense? Next one, constant velocity. I have constant velocity. My velocity here is constant. So my acceleration is 0. Then if I have increasing velocity means my velocity is increasing, right? So increasing velocity just means I have positive acceleration, so straight line. So if you notice, if I have a curve, become a straight line. If I have a straight line, it becomes a horizontal line. Horizontal line just go to 0. So basically, you can kind of see the downgrade of the relationship. Curve to diagonal, diagonal to straight, horizontal, horizontal to 0. Okay? Then if you have this kind of funny looking grade shapes, just take your ruler out, separate into parts that you can understand. So in this case, I will split it at 5.5 because if you actually notice, this left-hand side here and your right-hand side are different. This is increasing. This here is decreasing. Okay, so at 5.5, I should have, this should actually be a peak, a triangle. Okay, so what actually happens is at 5.5 seconds, I'm actually at my max speed or max velocity in this case. So you should actually have a sharp line like this. So depending on how you chop up the question itself, you actually have different parts. Because another student, he actually said if it was possible for him to actually chop up 4 and 6. Because he found that in the middle here, the 4 to 6 seconds, it looks like a constant velocity over here. So because of that, he said, is it possible? Yes, it is possible. Just that if you are supposed to draw this based off what he mentioned, the 4 and 6, what will happen is that your 6 will probably be at this point. So your gradient itself will actually be 0 because you say it was constant, and in this case, it will be a like this. Okay, so basically the top part here, you just ignore. It will look slightly different. Your graph will look totally different from the original itself, depending on how you interpret it or how you are expected to draw it. So just be careful. It's not always I give you displacement time graph, I ask you to draw velocity time. I can do the opposite. I can ask you this, and you need to draw it backwards. So just be careful. Okay, one last thing. Your uniform acceleration here, right? In the displacement time graph, we don't know acceleration because we can only find displacement, time, and velocity. There is no acceleration. So how do we solve this if they don't give us the diagram? Uniform acceleration means increasing velocity. So now, because of the term increasing velocity, I can draw increasing gradient. So this is how you will be able to sketch your displacement time graph in this case. Okay? Because not all the times they will give you the diagram. They actually sometimes give you the description, and you are expected to know how to draw them, and you need to be familiar with the shapes of the graphs. Okay?